With climate change shifting weather patterns around the world and fires continuing to rage in Australia and the Amazon, the question of how carbon gets stored, used, and released in the environment is getting more attention. Researchers from over 80 institutions are collaborating on a project to track how the carbon flows in a rainforest under drought condition and as it recovers. But it's not happening down in the Amazon, it's happening in Arizona. You know, the enclosed dome of the Biosphere 2 habitat? They're letting researchers use things like carbon-13 labeled CO2 to follow the flow of carbon through the air, the plants, and the soil.
One of the cool things about an enclosed ecosystem like the Biosphere 2 is that you can control the weather. So scientists decided, why not turn off the rain for 2 months and force this rainforest to go through a drought? And one of the big questions they have is what the plants are going to do with their carbon when they're stressed out.
You guys are measuring VOCs, which are volatile organic compounds. And from what I understand, these plants emit these compounds that sometimes even have fragrances. Connecting it back to humans, it almost feels like we're measuring the sweat of plants.
You can even measure human sweat, has a lot of volatiles. There are people who are measuring when people are in stress, we also start to emit a lot. It's not just only the plants, it's quite interesting. And it seems it's not only the plants, it can be the soils, it can be the microbes, and there's not that much known, so we really monitor everything. What we're setting up here is a measuring system, everything from the leaves down to the soil, where we can actually monitor. So we can see how the drought kicks in, how deep it goes, how the species respond, and then start the rewetting whenever we think we have that extreme drought we want to see.
Inside the rainforest is this fake hollow mountain, and inside that mountain is a room that was filled with very precise scientific instruments. And there was this spider web of plastic tubing that connected those instruments to every part of the rainforest. It was something like 2 miles of tubes.
Wow.
And they were constantly collecting gas samples from different parts of the rainforest and figuring out where the carbon was going.
These gas analyzers are organized together on streams, measurement streams that we use to look at the atmosphere, the leaves, the tree trunks, the soils, the roots, many different components of the ecosystem simultaneously.
So we know that forests soak up a huge amount of carbon, but we don't know exactly where that carbon goes. And that's because in the real world, you just can't track carbon cycles that closely. But the great thing about the Biosphere 2 is that it's a sealed ecosystem. So one of the experiments the scientists did is they closed all of the doors and they shut themselves inside for 4 hours. And I got to be in there with them. It was a great deal of fun. And they released canisters of carbon-13 into the air. So that's heavy carbon, and it's something they can track with scientific instruments. And then they had these instruments hooked up to every part of the rainforest to see exactly where those carbon molecules ended up.
We're watching to see the whole ecosystem draw down that 13 carbon as plants photosynthesize the CO2, fix the carbon, and then use that carbon to produce biomass, to produce VOCs, and do all sorts of things that we're tracking simultaneously. Since we added this unnatural amount of 13 carbon, we see a really large enrichment, and that's what this pulse represents. We open the tanks outside and let the CO2 flow into the atmosphere. It drove the 13 CO2 ratio above 1,000 per mil, which was our objective. And then we saw this steady decrease over time, and this represents the amount of that 13 carbon label that the plants took up during photosynthesis. We did this for over 4 hours, opened up the glass windows and flushed the system really fast to try to get this 13 carbon label out of the atmosphere so we could start to look for 13 carbon in CO2 that re-emerged because plants photosynthesized it, they fixed it, and then it got re-released from the ecosystem.
You know, if you're studying climate change and you're looking at ecosystems in the real world, they're very complicated and it's super hard to control all of the variables. But if you're just looking at like a potted plant or a greenhouse, well, that's pretty small and you're not really getting the complete picture. So this rainforest is the size of a gymnasium. It's been living and thriving for 30 years. It's the perfect place to do this kind of research.
So now we really see strong differences already. It was very species specific, so some species like these big clitoria trees here, they started to shed leaves early on, so it looks pretty much like autumn. Yellow leaves are falling down. Other plants hang in much longer, didn't show any visible signs, but we can see it in all our measurements, and now the soils really got very, very dry. We have lots of falling leaves, and now we're at this point where the drought is really severe, so we see leaves hanging down. Some of the plants start to look pretty bad, pretty yellowish. We won't let anything die here, but we are at the extreme drought point now. Well, C13 is the same like the normal C12 carbon is taken up in photosynthesis. This is then the baseline which can feed in anything. And the one thing we are, for example, monitoring is the volatile organic compounds. These are small little molecules which the plants are emitting, which actually give us the smell of the forest. And the interesting part is we can see in the moment that they're actually uptaking the 13 CO2 in photosynthesis. Already now on our instruments we see that they're already producing new volatiles from this labeled carbon, and we're already seeing it in the atmosphere. That fast, it's amazing. And it's really interesting to see how this is happening. So at the moment the main part comes from the leaves, but further on in the next days we wonder how it goes through the trunks, through the roots, and then also the soil plays an important contributor. At the moment the soils can take up also the atmospheric molecules, but then it will go through the roots, the carbon fed into the microbes, and they might also release or take up other VOCs.